Alrighty guys, looking at 5B linear models, what you've got to do is either graph it or look at the graph and work out how to find out information. Our first one is our GBP versus Australian dollars. First question is quite literally looking for 30 Australian to pounds. So find where 30 Australian is, cross it straight over, it's just under the 20. So we're going to put that in, it's around about 18. Next one is looking for 50 pounds. So let's go back over, find where the 50 is, go all the way up, go across, and that is sitting right on the 30. Third one is 20 pounds going to Australian dollars. So we're starting up on the vertical axis where 20 is, making our way over, and it is sitting between 30 and 40, but not quite at the halfway mark. And for find the 10 pounds, drawn all the way over, and it is sitting between the 10 and the 20, but just past the halfway mark. Last question is looking for the gradient of the conversion graph. So find 2 points that sit right on, and we do have, of course, the point 0, 0 and the point 50, 30. So our rise was 30, and our low was 50. 30 over 50, of course, simplifies to 3 over 5. One of the more difficult questions looking at an electrician charging $50 to a call out and $80 per hour. Assuming the relationship is linear, you need to find the formula of the cost in terms of the time spent T. So important information is the $50 and the $80, and we're of course going to be putting it back into our y equals mx plus c formula. So cost equals our gradient times T plus our y-intercept. So up here it does tell us that $50 was our y-intercept. And we're going to find, obviously, that our per hour 80 should end up as our gradient. So we should be going straight in where our m was. So we end up with cost C equals 80t plus 50. Now we're drawing the graph of C against T. So we knew that our y-intercept is going to be 50, and it is going to be going up from there. Now you will probably want to use a different scale to the one that I use here, because my scale does end up making my graph look a little bit very high at the front end and doesn't really make it very far out. We are going to start at that 50 mark though. That top 50 should be a 250, I'm not sure why I missed the 2 on that one. And it is our hours along the bottom. Alrighty, first one, when it's 0, he gets $50. So let's put in where our intercept is. When it's 1 hour, he gets 80 times 1, which is 80, plus $50, and 80 plus 50 is, of course, going to give us 130. So we need to go straight up to just under the 150, but further than 100. And that gives us our line. That's what I'm talking about there. My line is very steep. You can use a different scale for yours to make it a little bit more useful. The next one is calculating the cost of a job that takes 2 hours and 45 minutes to complete. We can quite literally just throw the numbers into the formula. I'm sure that you all know that 2 hours and 45 minutes is the same as 2 3/4 hours, 45 minutes being 3/4 of an hour. I'm going to add 50 to the end of that, and I'm just going to jump over to a calculator, and we've got our 80 times 2 3/4, and then we're going to add our 50 onto the end of that, giving us a total of 270, and that gives us our answer back on the original page. It's going to cost 270 to have him for that long, and that's it.